Hi, my name is John.
Hi, I'm Sean, and our team name is Aeropile Drivers. We are Year 4 Civil Engineering students from the National University of Singapore. Our proposal title today is Low Carbon Concrete with High Early Strength. So now we'll be going through our presentation outline. Firstly, we'll be going through our background, our innovation, which is LC3, the process of getting LC3, the advantages and the impact of LC3. Before we talk about our innovation, we'll first talk about the background. With the rising effect of global warming, civil engineers are at the forefront of climate change mitigation. Currently, 5 to 8% of man-made CO2 emissions are from cement production alone. As future generations of civil engineers, we can propose innovative methods to cut embodied carbon through the selection of low carbon materials and green construction processes. Secondly, marine clay is a waste material widely distributed in the coastal regions and countries. It has weak soil properties and cannot be used for construction and foundation material, and typically sent offshore for removal. Our innovation is limestone calcined clay (LC3) cement, which should solve both the issues we mentioned above. Studies have shown that when clay is calcined and added to limestone to remove cement, there's promising results with the strength of the concrete, especially in the early strength. Henceforth, we approach this proposal with this idea and how we can use it as a supplementary material that can positively affect our concrete strength, especially in the early age strength. The two main components of LC3 cement is the marine clay, which is actually ball milled and calcined by heating to 700 degrees Celsius, and limestone, which is a widely available material that can be supplied from local chemical factories. So with that, I'll pass my time on to John to talk about the processes.
Next, I'll be talking about the process of getting the calcined marine clay. Firstly, we would break down the marine clay into smaller pieces and then air dry it for 1 week. Second, we would oven dry the marine clay at 100 degrees Celsius for 24 hours. And this is followed by putting through the oven dried marine clay through the jaw crusher. And as seen from the photo, this is the marine clay after the jaw crusher, and we can still see that there are still some relatively big particles. And hence we need to put this jaw crushed marine clay into the ball mill so as to get final marine clay as seen from the photo beside the ball mill. And lastly, we would calcine this ball milled marine clay by putting it into the oven at 700 degrees. And also I would like to share about the research done in NUS. And this news article, as you can see, features NUS research on marine clay, which is the first in the world to use marine clay. And the studies that has been done has shown that using marine clay in concrete will be able to reduce embodied carbon by up to 50%. And next, I want to talk about the advantages of LC3 cement. Firstly, in terms of its strength, it is able to give good early strength as the fine clay particles are able to react faster than fly ash. And also, LC3 cement is able to give comparable long-term strength, as a research done has shown that the mechanical properties of concrete with LC3 binder are comparable to those of the reference pure cement mix from 7-day onwards. And in terms of the sustainability part, calcination temperature, which is at 700 degrees Celsius, is lower than cement clinker production at 1400 degrees Celsius, and hence the calcination process uses less energy. And because the calcination temperature is relatively low, the use of expensive and complex machinery is not needed. And thirdly, LC3 cement does not require the use of special or high temperature curing or mixing, which helps to increase the production capacity and sustainability. And lastly, replacing cement with limestone powder and calcined marine clay is able to reduce the carbon footprint. And last but not least, I want to talk about the impact of LC3. Through this use of LC3, we are able to reduce waste and recycle this waste into a useful product. As a result, a circular economy is formed, which would reduce environmental issues like pollution, loss of flora and fauna due to excessive dumping of waste, and global warming issues. Second, we are able to save the material costs, and because of this saving, we are able to free up money that can be spent on social causes. Thirdly, we are able to boost the resilience to supply shortage. And with that, we come to the end of our presentation, and we thank you for your kind attention.